Doing strong acids and strong bases are relatively straightforward. You have to calculate the molarity of the acid and then determine how much hydronium there is, or calculate the moles of base and calculate how many moles of hydroxide there are, uh, just based on the concentration of the acid or the base. Now, weak acid calculations are a little bit more difficult, but they're very doable. They're very similar to the previous chapter on chemical equilibrium. So what we're going to do is we'll set up an ice table, and we're going to I'll show you how to calculate the pH of 0.20 molar hypochlorous acid. Its Ka value, which I listed before on a slide, was 2.9 times 10 to the minus 8. So you have to make some assumptions here, but let me go ahead and fill out the ice table for you. And so, draw your lines like this. And then I'm just going to X out this whole column because that's water, right? So I don't want to get confused and be putting things in there. And I'll put a line between the acid and the hydronium and the conjugate base. And then the only number I'm given is the 0.20 molar. So I'm going to just drop that in here. And then I make the assumption, like you do in a lot of equilibrium problems, that there's no product present initially. And then what will happen is then it'll go to the right. So this will be a minus x, and then a plus x, and a plus x. So this is 0.20 minus x, right? And then the right side is just x and x. So when I take my Ka expression, that's going to be equal to x times x, or x squared, right, divided by the concentration minus x. And a lot of times I put parentheses down here just to remind myself when I'm solving them to use parentheses for the denominator. That's going to be equal to 2.9 times 10 to the minus 8. Now, to solve this problem requires using a quadratic, and I'm just going to rewrite this as x squared. Or if you watch the video introduction for the worksheet that's associated with equilibrium calculations, you can also use the solver on your calculator. So actually that's the approach I'm going to take. I'm going to not use my calculator solver. I'm just going to open up Wolfram Alpha and solve it. Yeah, so actually what I thought I'd do is not use Wolfram Alpha. I'll just show you how to do it if you have like a TI-84. Or the 36X Pro, the one that I recommend, has a solver feature in it. And this is just the emulator for the calculator because I don't have the calculator anymore. But what I'm going to do is show you how to use the solver. So we'll go to Math, and then the solver is the bottom function. So you notice I hit the up arrow, so now I have the solver. And so I'll hit enter, and that'll take me into the solver mode. And then what I need to do is type in the equation. So the equation is x. So I'm going to go second. You got to find the variable x. On some of the calculators, oops, I hit the wrong button. It's alpha x. Sorry. Some of the calculators have the function built in directly for the variables. There's an x, y, z button, and you just click that to get the variable you need. And then I'm going to say divided by, and then a parenthesis, because I have a parenthesis there, 0.2 minus x. So 0.2 minus x. And so again, I'll have to use my alpha, and then I'll have to use my x, like that. Or not. Maybe I didn't. Alpha x. There we go. And then you notice this says E1 equals E2. So I'm going to go ahead and go down here. And this is where you put your equilibrium constant. And so that's going to be 2.9. And then the scientific notation button on this calculator is a second function, EE here. And then that's supposed to be minus 8 in our problem. So we'll say negative and then 8 like this. So that's entering the equation, and now I just have to enter. And I'm going to leave this as 0, and it's showing me the equation up above. And then I'm going to solve it. And you'll notice it says press alpha solve. There's alpha, and there's solve right there. And it goes and it finds numbers, right? And this one is 7.61 times 10 to the minus fifth. That is one of the roots of this equation, the value of x that satisfies this equation, which basically says this left side is equal to that right side. It turns out this is a quadratic equation, so there's probably two roots, and you do need to know how to pick those out, and that's something that's covered in the worksheet that we do on this topic. But I can take this as 7.61 times 10 to the minus fifth as my value for x. Okay, so now I can relate this to concentrations, right? So this is my hydronium concentration. It's the value for x. So to calculate the pH, I'm going to say pH equals to negative log of x, right? So like on my calculator, this is kind of one of the magical things about having this calculator. This is the value for x, right? So I'm going to quit. And then I'm going to go negative log, and then I'm just going to stick x in there because that's what I just solved for. I'll hit enter. And it's 4.12. So that's the pH of the weak acid hypochlorous acid at a concentration of 0.2 molar. Now, if you really want to, I'm not going to go through this process, but if you really want to, you can solve the quadratic and get to the answer like I showed in the last chapter. Or you can use the solver or Wolfram Alpha. I personally recommend using the solver on your calculator just because that's something that you'll have with you all the time, and it's very useful to know how to do. There's a concentration, right? And of cyanic acid, HCNO, and it has a Ka, and just to help you out, but I'll work the solution out after I pause this and let you try. But there's a Ka that I got from the 4th edition of Tro, and the reason why I said the 4th edition is because it turns out that these numbers get updated periodically, like more frequently than you would really like. As people dig and find different values. And so, yeah, it's important to know that that's from the 4th edition of Tro. When you solve this, you should get a pH of 2.42. It's considerably more acidic than the last one I did, even though the last one had a higher concentration. Anyways, let's go ahead and I'll pause it, and then I'll give you give yourself about 4 or 5 minutes to work out the equation and then solve it. And then we'll come back when you start it up again. I'll run through that solution with you. Okay, so this is the setup for it. I'll just walk you through it. I needed to write out the acid ionization equation, so it's just the acid plus water. You notice I did the generic form here. I didn't write the actual formula, and that's completely okay. And I just say to myself, A minus is CNO minus. So 0.075 is my initial concentration, right? And then assume there's none at the beginning. And then this will be minus x, x, and x. And so this becomes 0.075 minus x, and this becomes x and x. And you'll notice this is the expression for the equation. And so now what I do is I say Ka is equal to 2.0 times 10 to the minus 4. And then I used the calculator emulator, and I plugged in the equation, and I solved it for x. And that's the 0.00377 that I have here, and that's the value that's listed down here. Okay, so to calculate the pH then, pH is equal to negative log of the value of x, and that comes out to be 2.42. And again, lower pH values are more acidic and higher pH values are less acidic or more basic. And so in this problem, even though this concentration is much higher than this concentration, this pH is 2.4, and this pH is 4.1, and that really has to do with acid strength. This is a much, much weaker acid. It would be very hard to use this acid to get a pH that's this low, unless the concentration was very, very high. I'm not sure you could even really do it. Okay, so again, this is how you do these calculations. The same types of calculations are used for bases, and we'll review those next.